start recording right now.
Okay, thank you.
Okay, so I want to do this. So what is the technique? The technique is to have an integrator. At the output, I have x. And so here I have x dot. And x dot is minus x, so I have to place some gain in which x enters, multiplies by minus 1, and goes there. Okay? So it should do something like this. We did one example like this, but now let's do it more systematically, and then I will do something more complicated. Okay, this is one thing. Now suppose that you have x dot equals to minus x plus u. Okay, and u is an external signal. So in this case, again, I have my integrator. I have my x dot, and then x dot is a sum of minus x plus u. So I put here a summation point. I need again minus 1, and I need something that comes from some signal generator, for instance. Okay, so let's try to do these examples. So stop share. Let me start my MATLAB. Takes a little time. Maybe I should have done it before, but now we have to wait a little bit. Okay. So can you see my MATLAB screen?
Yes.
Yes.
Okay. So I will run MATLAB. Okay, so let me do one thing. So I will create a directory, and this directory can be it's a directory on my disk. So I have some monolith simulation controls. Okay, this is a personal directory, so don't look for this in your computer because you don't have it. This is in my computer. And I do it like, okay, test. Okay, so I have a fold called tests. I go there, and then I click here, Control C. So I have the path to the test, and now I go to MATLAB, and I'll do this command cd. Then between quotes, it's the string. Okay, and I put the path between quotes, single quotes. You see here and there, return. And at this moment, I'm positioned, MATLAB is seeing my directory. Okay. So when I do save or load, I will be doing save and load from this directory, and or folder if you want. You can see that the folder is empty. Okay, the folder is empty. So let's open SIMULINK. So I go to the SIMULINK library. This version is already 5 years old. Probably we'll have newer versions, I don't know. So it's opening SIMULINK. Okay, so this is the SIMULINK window, and I have the library of blocks. I can select different blocks here. But the first thing I need is to open a project. So it's a blank sheet, blank piece of paper where I put my elements. And this is done here, new model, you see? So I click here, and it opens the new model. All right. So I will place my model here. And you see it's untitled. So at this moment, this exists only in the memory of the computer, not on the disk. So I need an integrator. And I go to continuous. And I select the integrator. The integrator is here. Okay. So I click and I drag it here. Okay. Now I will give some initial condition, say 5, whatever you want. And for the moment, let's ignore everything else. Okay, so I do here OK or apply. If I do apply, it applies the values I gave, but does not close it. Okay, now I need a gain. So again, it's on mathematical operations. Where do I have mathematical mass operations? Okay, here. And you see I have summation points, multiply or divide, internal products, gains. So I need a gain. I will put it here. Okay, and I could do the connections in this way, but probably it's more elegant if I flip this block so that it, instead of having the input on the left and the output on the right, it's the opposite side. So I click with the right button of the mouse and then flip, rotate and flip, rotate and flip, flip block. Okay. And by default it's 1, but I want it to be -1. So I put here -1. Okay. Now this is connected to here. I can select the wire and make some adjustment. And this connects to there. So I can do the simulation, but I want to see my simulation. So I think that I gave you an example in which I connected here some scopes, but let's do it in a different way. So instead of connecting a scope here, I will send it to the workspace of MATLAB. Okay, so you have SIMULINK, and SIMULINK, the variables exist in some space or some piece of memory related to SIMULINK, and MATLAB has another piece of memory. So I'm going to connect both pieces of memory. And I can do this with, I go to Sinks, to Workspace. Okay, and then to Workspace, I can give the a name to the variable. So I call it X. And also you see that the format is important. So the time series gives you time and the value, but I prefer to have array. So array is a vector of numbers. So I connect it here. And now I have one problem, which is the time. I need to have a connection with time. Time is being generated internally, so I have to see it. So I pick up a clock, and clock is in sources. Is some signal that is generated by this block. Clock generates time. And then I have to send the output of time also to MATLAB workspace. So I could have picked up another block of this type to workspace, but I can click here with the right button, and you see it copies. Now I will call this T. You can call it whatever you want. And I connect it. Okay? Now, to do the simulation, I must decide a number of things. So I go here to simulation and model configuration parameters. Just a moment. Okay. So you see that you have a lot of things here that you can select. In particular, you can the start time and the stop time is between 0 and 10. I could have changed this. Let's put, say, 5. Okay, so it's going to simulate the system between t equal to 0 and t equal to 5. Now, there is you can select the numerical method. That's the solver. Okay, the type is a variable step method, and the name of the solver is ODE45. Okay, so ODE45 is a routine that is called and implements some numerical method. You know one basic numerical method. What is the name of it? If you want to integrate a differential equation, remember I told you about one method. Remember the name? Euler. That's good. Euler. That's right. Euler. You know that Euler was blind? No?
No.
Well, he could see from both sides, but he lost one eye due to some illness, and he was sent away from the Academy of Sciences of St. Petersburg. Not St. Petersburg, but from Berlin, because it was considered that it was inappropriate for the official mathematician of Prussia to have just one eye, so he was sent away. And he went to Russia where he was very well received, and he became blind of the second eye. He tried to prepare, but he trained himself writing without seeing, but it was impossible to do it. So he was dictating the results to a nephew. There was a nephew who was writing what he was dictating, and his comment was, "Well, I have less distractions." Okay? So Euler method, invented Euler method. Now, This OD45 is based on a version of another method called Rungakuta. Okay, it's another method. It gives you better approximation, but of course it's more complicated. And it's variable step. This means that instead of having always the same step in time, so you suppose that you are integrating every second. So you have at 0, at 1 second, 2 seconds, 3 seconds, and so on. Sorry. With variable time, you are varying this interval depending on how smooth is the solution. If you have something which is almost constant, why to have samples every second? You can have it every 10 seconds. Okay, you save computational power and space, memory, and so on. Now, if things start changing, you automatically decrease the step time. Okay. Now, how do you do that? How can you control that? These methods work in this way. So, the method, suppose that your basic step time is 1 second. So the method computes after 1 second and then after 2 seconds from 1 second. Okay, so there's 2 steps, 1 to 1 second and then from 1 second to 2 seconds. And then there's another thing, which is to compute just once with 2 seconds of step time and compares both solutions. If both solutions are the difference between them are smaller than this relative tolerance, then divided by one of them, then you go on increasing the step size. Otherwise, you decrease it until you are at a limit in which they are both good. Okay, that's the way they work. So usually this 10 to minus 3, this should be, what is this number here? 1e minus 3. What does it mean?
10 to minus 3.
10 to minus 3. Okay, don't get confused. This is not the e of the exponential. This is the so-called engineering notation. Means that this is 1 times 10 to minus 3. Okay.
0.001.
0.001. Okay. So usually it's better that you do it, say, 1 or 0.00001, 10 to minus 6. Okay. Later we can see what happens. Now, this is everything you need for the moment. Okay, so usually you have to settle the stop time and the tolerance. The stop time can be a variable in MATLAB. You see, you can write in this. You can put here, say, capital T. Later we can do an experiment, and from MATLAB you can control this. But you can also open this this window and write it down. Okay, so we have done this. And where is our model? It's here. So to do the simulation, if everything is okay, I just press this button, this green button. Okay, and I press the button, and the computer starts burning with a lot of smoke, and there is a message saying, go away, otherwise you will be injured by the explosion in the next 5 seconds. So you have to accept. Okay, apparently it did something. While I was saying this rubbish thing. So let's see, let's go here. Now, look here, you have the workspace. This is the workspace of MATLAB. So this is the memory of MATLAB. It was empty, but now you have T. I really don't know what is this T out, probably something that I forgot to and it's there, and X. Okay, let me look at we have T. Oh, yes, oops. No, it's okay, should be. I don't know what is T out. And you have the X. Okay, so if you write, now let's go to MATLAB. If you write T, you see that you have, this is quite regular. So you have initially, now it's 0.0 every 0.05. Okay, it's quite regular. Sometimes it's not. And if I do X, it appears. This is the values of X. Okay, so T is a vector with all the elements of T, of time, and X is the vector with all the corresponding elements of X. Now, I want to plot. So if I do plot, it will appear. But let's be more clever. So what I'm going to do is I'm going to create a script. So it's a small program. For that, I have these buttons here, and I can open an editor. Okay, so I say new script. New script. Okay, sorry, I had it already. So it's untitled, and it's just in the memory of MATLAB, and you can edit this here. Okay, so we can say café is no, not café. Emaxi is Nebissa, folha de hortaliça. You understand? Maxi does not like that, so let's read it.
I think cafe is not understandable.
Cafe is something. Okay, let's translate it.
I think that's only me and Maxi are okay.
See, yeah. I can see the eyes of Emaxi. Okay, so this is something where you can write things. So let's write commands for MATLAB, and then these commands you can in MATLAB just write the name of this file, and it executes these commands. Okay, so I can put a comment here. Okay, a comment here. Plotting simulation of the, okay, so the fact that I have this percentage symbol means that everything else is ignored. It's a comment. Can write everything, it does not matter. So everything after this comment is ignored. Now I can open a figure, I think it's 1. If it does not work, okay, sometimes it is clever and sometimes opens here, gives you some hints on the errors and so on. So it will open a figure that I call figure 1. Could be figure 5, figure 10, whatever you want to call it. You want to number it. Now, I will do plot X. Okay. And then usually I write this. And of 5. Okay. Just to say that these are comments. Okay, nothing else. So let's store this. Let's store it. you see that it was auto-saved here. It appeared here as untitled. So I'm going to save. Save. And I have to give a name because it's the first time. So
you're not saving it. You're opening you are opening a new file. You are not saving
I'm
it.
saving as the first. I'm saving for the first time. That's creating a new file. Yes, but it's saving in a new file. Okay, not saving in an old file.
I'm just saying that I think you didn't click on the save file button. You
Yes,
clicked on
but
the open file button.
it's creating. You see that it opened. It's clever. You don't have save as here. Okay. If it is for the first time, he recognizes that, so he asks you for the name. He's asking me for the name. You see?
Oh.
Okay. So it's different from in Windows. You have save and save as. But I think even Windows, if you save it for the first time, it gives a name. It gives a name. It tells you document one. Here, for the first time, it recognizes that it's the first time and asks you for the name. So it's the same as save as, but there is no button for save as.
Okay. Thank you. Okay, thank you.
Okay, so let's give a name. Sim, be careful with the names, not sim example one, sim x1. Okay. And sorry, I did something that I shouldn't. No, it's not open, it's saved. Save as, okay, the save as is here. Okay, so you see that the path is correct. And I was telling you a bunch of lines. So you have the save as and the sim x1. Okay. Now I have it there. I have it there, you see. So this is your directory, and this is MATLAB memory. And in addition, you have SIMULINK memory, which is another thing that you are not seeing. Okay, now let's run it. To run it, you can do in two ways. You can come here to MATLAB and write simex 1. Okay, and you see the solution. Figure one, and this. Okay. Now, suppose that you want to label the axis. So you come here and you write X label, and between quotes, this is a string. Okay, you can have string elements, and you have instructions to work with strings. For instance, converting a number to a string. One thing is 15. The other thing is the string character 1, character 5. Okay. Sometimes you have to do it because when you write something in the graphs, you always write a string. Imagine that you were doing simulations for different values of a parameter, and you want to write the values of the parameter. So you have to convert the parameter to a string and then write a string to identify on the graphic. Okay. So I do X label time seconds. Okay. And Y label and I call it X1. Okay. Now you can write subscripts and superscripts. Are you familiar with LaTeX?
Yes.
The word processor? Yeah, Maxi, yes. What about you, Jose?
Yeah, I also already wrote some papers in LaTeX.
What about writing a paper? you only learn LaTeX by writing papers, not by reading books about it. Okay, so
No, I
word
wrote the
processor.
paper only.
Oh, you wrote a paper, so you are familiar. Café?
No. I'm not.
No, but you should. Okay,
Okay.
you should learn. It's the professional way of writing things. I mean, all books now are written in LaTeX, and the good scientific papers are written in LaTeX. And this supports some commands. For instance, suppose that you want to have some variable which is x1. It will appear x index 1. And you put the quotes to say that it's a string. Okay? Okay. So let's see what happens. Not the semicolon. Let's see what happens. So instead of writing here, I will just push this button for run. And it will run what is in the editor, opening the editor, okay? I did some mistake here. Oh, it's here. There was an extra curl. Now it's okay. Let's save it and run. Okay, it echoes there, and you see time as x1. You see, it works. Now you can have a title, or you can have a text at some coordinates. I will not do it. One thing that I like is to have a seeker line. So this is an object. This is an object. And in particular, you would like to increase the thickness of this line. This line is part of an object, okay? Or it's a sub-object in the picture. So the picture is made of elements, okay? Each element is a subject. It's an object, and you can say the color or the thickness or some properties, if it is a dashed line or it is a solid line and so on. So you can control it. You can control it. Now, I want to refer to some properties of this plot. So I have to refer to the plot. So I use a handle, and plot generates a handle. A handle is a variable that identifies the plot. So instead of saying that plot, you write plot number, I don't know, the number that he gives, 55 or 33 or 34. So I write here, some variable can be anything, gg equal to plot tx. So this gg is a variable, and this gg has the number generated by MATLAB that identifies this plot, okay? Within figure 1. Now, to avoid having the number of gg, because I don't matter, I put a semicolon. And then I can say things about the plot. I call it gg, okay? So I see set, that's a function, gg, so I'm setting some property of the object gg. And in this case is line width. And I put 1.5. This corresponds to, and that's it, okay? And also here, I can enlarge the size, the type of the letter. So I write here gg, put a semicolon not to have the value of gg, and then I said set gg, and I put font size. I use a font size of size 14. Okay. and also in the other one. So I have here g equal and set okay. So what is going to happen? What is going to happen is that you have the line is seeker, will become seeker, mais espessa, and the size of the letters will be bigger. Okay, so let's see what happens. So I save it and I run it. And you see this is bigger, and the line is clearly thicker. Okay. Now, suppose that I just want to see what happens between, I want to see what happens between 0. I want to change the scale of the plot. So this is automatic. Okay? And MATLAB is optimizing the scales between 0 and 5 and 0 and 5. That's quite beautiful. Suppose that I want to see what happens between 0 and 1 and in time between 0 and 5. So I can write something here, axis, and then x mean. You see that it gives some hints. Axis. Or there is axis and axis. 0, 5, 0, 1. So x mean, x max. Sorry, this is t mean, t max, x mean, x max. So the limits of the first of the horizontal coordinate and the limits of the vertical coordinate. Let's see if it works. Not work. So it's axis. I was correct. Axis. Okay. Now you have the axis between 0 and 5 and 0 and 1. So you can control it. Okay. There are comments that allow you to put multiple graphics and so on, but later we can see that. So I close it. I close this. I comment the axis. Now, suppose that I want to do several simulations. Okay, several simulations. And I want to do it without, I want to do 100 simulations for 100 different values of K. Okay? So I don't want to go on and changing things by hand, because to do it 100 times I would be tired. It would not be possible. Sometimes you want to do many simulations changing one parameter. So you can have comments to do the simulation controlled from MATLAB. Let's see what you can do. Well, remember that I told you the final time can be changed. So I can put here simulation, remember configuration parameters. And then instead of having here stop time 5, a number, I put a variable T, capital T. And then I come here and I have to define T equals, say, to 8. Okay? And I put a semicolon not accurate. Then I can give the order to simulate by using simu. and between quotes the name of this system. Now I have to give it a name. It's not saved. You see that there is a star there, meaning that it's not saved. So I will save this as, the extension is SLX. I will call it X1, okay? X1. And here it is, X1. So you have simex.1, this is the script. And this is the block diagram. It's the extension SLX. Now, if everything is okay, I can even close this. I can even close this diagram. Let's close it. And it's clever enough. He finds the file and runs it. So let's run it. Oh yes, simu x1. Okay. So we have this command simu, and then the name of the file without the extension between quotes. You can add more options, controlling the precision, controlling even the final time, and so on. But this is the basic one. Now it should work. No. No, it's not simu, it's sim. Okay. And you see it goes to wait. Now, let's close it. And
excuse me, may I just a second? I will come back. Just a second. I will go out. I will come back. Okay. Just a second. I will turn off my.
You want a time break?
Yeah. No. Just for 5 minutes. Yeah.
Yes.
Okay. Okay. Sorry.
I will wait for you. Meanwhile, I will read the post that arrived to me. Okay, it's a bill. Now, when you receive some letter, is to pay something. This is to pay to the Chinese. They let EDP. You know what is EDP?
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 Yes.
Yes. Everybody in Portugal knows what is EDP. So let's wait for a moment. So this letter I won't open it. Estão a seguir isto? Bem?
Yeah.
Aprenderam qualquer coisa ou não?
Claro.
A Maxi se calhar já sabia estas coisas.
Já tinha trabalhado com MATLAB e também.
Ok, então agora vamos fazer um exemplo mais complicado a seguir. Temos aqui meia horita. Vamos fazer o outro exemplo mais complicado. Depois o truque é ir explorando estes diretórios. Tem o help, não é? Se eu quiser saber qualquer coisa, por exemplo, se eu quiser saber qualquer coisa sobre xlabel, help xlabel. E ele diz-me, não só me diz como é que eu devo usar o xlabel, não é? Mas depois diz-me várias coisas, porque eu também posso ver o Y-label, o Z-label, isto funciona com gráficos em 3 dimensões, title e o text. O title é para pôr uma linha de texto em cima e o text é para pôr uma linha de texto lá no meio, por exemplo, identificar uma curva, fazer qualquer coisa, escrever qualquer anotação. Portanto, é interessante a gente, mesmo comandos que conhece, fazer o help porque ele depois diz dos outros comandos que podem ser úteis e a gente vai aprendendo assim os novos. E depois há o doc, e o doc é um manual com exemplos, com estruturado. Portanto, se eu fizesse doc label, ele abre-me aqui uma janela ao lado. Estão a ver? E tem aqui assim o manual do MATLAB. Okay?
Uhum.
Examples and how to. Tem aqui exemplos. Ok? Portanto, habituem-se a explorar o help e o doc. E vão aprendendo assim. Eu sou nabiço a usar estas coisas. Não é? Há um programador profissional disto faz coisas que para mim são impensáveis. Um aluno que faça muitas coisas também usa montes de truques. Isto nem é propriamente programação, que é só o controle. Vou esperar um bocadinho mais pelo cá, ver o que é que aconteceu. Então, para ganharmos um bocadinho de tempo, deixem-me abrir aqui uma coisa. Que é para o próximo exemplo, para ficar já... Aí vem, ok. Ok, e escapei. Now, let's see, so...
Sorry, I just...
I think that now we can change things now, okay? For instance, if I change this to 3 and I force the axis to be 0505, I can change also parameters in the simulation. Okay? Now, let's do one trick. Suppose that you... Okay, I don't have the diagram here, so I write the name, and the name was X1, and it appears, okay? Now, let's change this parameter here, gain. So my gain will be, I call it K. Okay? Okay. And it appears there, okay. Now, K must be defined in MATLAB, value of K. So I save it. So I can do this. Equal to 5. And then K equals to -1. And then I simulate and I do everything here. Okay? Now, I do this. Hold on. And when I write to the figure, it will keep what is there. Instead of cleaning and rewriting, it will keep it open. So I will do K equals to -2. And then everything here. So I close the stuff here. I put another value of A. On, and then I repeat everything. So no axis, there is no. Also the labels, they are already done, so I don't need this. Okay. So what happens? Okay. Now it changed the color automatically. Now you don't know which is which. If you want to know which is which, you want to control the color. You do plot, and you can use the color, comma, and then the color. Black. What is the letter for black? B is for blue, so it's not B, it's K. And sorry, K. And here you put comma, open the brackets, open the prime, and let's use it red. Okay, so blue is -1, red is -2, and now you know is blue, now is black. Let's put it green.
I'm really sorry to interrupt, but I need to go to the bathroom and I come back.
Okay.
afterwards.
Okay. So we have this thing, okay? You could, if you want to compare some curves, you can do this trick. Any question?
No.
Nope.
Okay, let's do something which is more complicated. Let's give some time to Jose. And let me pick up one slide. And I will then post this slide on your, so that you have access to it. So let me write this in a piece. Okay. So let's simulate this tank. Okay, let's simulate this tank. And H is the level. H is the level. You can get this equation by applying conservation of mass and conservation of energy, but don't bother for the moment about that. So H is a level, and capital A is the area of this cross section of the tank, constant, and small a is the area of this hole in the tank. Imagine that you have here a valve and you can control a, so you have a variable that you can manipulate to keep the value of h constant, for instance, despite what enters. U is the input. Okay? Is the input flow. So let's simulate this stuff here, and you have some initial level. You have some initial level. So let's simulate this stuff. What can we do? Again, it's the story of the integrator. So the integral, you have h, you have an integral, the output is h, the input is the derivative of h, so you have to put this equation there. So let's do it in MATLAB, in SIMULINK. So I will close this stuff. And I will consider another example that I call save as tank, sim tank. And well, I will write things here, but what I really want to do is the different projects. So let's close this one. Let's pick up the SIMULINK block and let's open. The project is here. Open model. Open new project here. New model. Okay. So we know we need the clock. Is something that we need. And then we need something to transfer the variables. So this to workspace block. I call it T. And don't forget that this should be array. Okay. Now we need an integrator. So continuous. And we pick up the integrator. We pick up the integrator. Now, the output is the level, and the input is the derivative of the level. And now it's a linear function. Of course, you have here many elements in the math operations. So you could work with this to try to write that function, but you have functions, user-defined functions. So you have several types. The S functions allow you to write dynamic SIMULINK blocks. Okay, that's quite powerful, but we won't speak it, and you won't need it in this course. But if you want to do some certain sophisticated things, you should use S functions. For the moment, let's use this FCN, this function. Okay, user-defined function. So I put it here. Okay, and I connect it to there. So this is the derivative, and the input. The input is H. Now I have to program it. And you can write things assuming that the input, you can have several inputs. You see U1, U2, etc. Now you only have one input, so you only have U1 or even U. I think that if you write U is okay. So, and my function is this. Let's assume that the cross-sectional area, okay. Let's assume that the cross-section area is 1 to simplify things. So this should be minus a. Don't forget the times is something that now we have the square root of 2g and the square root of 2g. Let's go to MATLAB. Is 4.4, okay? 4.427. I said, okay, let's say it's 4, okay? I just write 4. So where am I here? No, I'm here. So times 4 times the square root of h, but h is the input to this function, so I call it u. It's the by definition the variable that enters u plus. Okay, now we have one problem, which is that flow that flows into the tank. So let's assume it's 0 for the moment. So we don't have it here. Okay, in a moment we are going to change that. Okay, so we have to put some initial condition. If it is 0, it will become 0. It's nothing as simple as that. So let's suppose that we have 0.5 meter. And then we have to send h to MATLAB. So I put here h. Okay. And configuration parameters. Let's see, simulation. Model configuration parameters. Now let's put some final time t. I want to adjust it. I put here at -6, and that's it. And then I save it. And then I save it, and I call it sample2, example tank. Okay, example or tank. This is our tank. Tank. We have sim tank, so we can use the word tank. Tank. Okay. So sim tank is the MATLAB script to do the simulation, and tank is the model in SIMULINK. So we could pick up the previous script. And copy it here. And now we edit it. We say simulation of the tank. Okay, let's start with equal to 5. Now we have the parameters is, one of them is a. Let's put a equals to 0.02. Now I want to simulate this tank, the name of the SIMULINK figure. Now it's x, x, and I don't need this. I also don't need this. I put a comment. and this is H meter. Okay, let's see if it works. If it gives you something. Okay, so you see the tank discharging. The tank discharging. Suppose that you simulate not up to 5, but up to 10. What happens?
It goes to
Let's
0.
put here a narrower output, and let's put here 10 seconds. Okay, let's put even more, 100.
Okay.
Okay, and you have the simulation. Now, we have a problem here because the level is becoming negative, so we should what happened, let me see, it should never become negative. Let me look at the model. Now you should correct the model if you have a problem. That's why it has this this value, which is strange because it's taking 0 when the negative is, when the h is becoming negative, you have a square root. So let me see, let me look at the SIMULINK model. Don't get confused with this u, minus a, 4 a, I don't know why should this ever become negative, because for just in case, let's close it. Don't forget to clear the variables. Because you can have garbage, podem ter a lixo das variáveis anteriores. Por exemplo, se fizerem como a variável, if you do a simulation with a large value for time, then with a shorter value, okay, there will be some interference. So always do the clearing, clear all, clear. You see, no variables here. The memory of MATLAB is empty. So let's simulate this now. For some reason, it's becoming negative after this value. So let me put this smaller. See what happens. Okay, it takes more time. It's not a straight line, you see. So you can change the parameters. Now, Okay, there is something. Okay, you can put here, and this it gives you no more. You see this message. So by putting the semicolon, you avoid that message. Clear. Clear command CLC. Close all figures. Close all. Okay. So let's do it again. There is still one there, but you can see the. It's doing the simulation now. Now, let's remember that you have the term of the water coming in. So you have an extra variable, Now, what do you do? What do you do? Let's look at this function here. So this function, you only have an error there, but this error can be a vector. So what you do is this, clear this, and use, let's go to the SIMULINK. You have signal routing. Okay, signal routing. And you have this multiplexer. Okay, so let's use it. So what is this signal? You have a number of inputs, and the output is a vector, becomes a vector. Okay, in this case, you have 2 inputs. If you had 4 inputs, you would have 4 inputs there. You see? But we only use 2. So we need only 2. Okay, so we put it there. And this line now is something that corresponds to a vector. Okay, the first component is the vector, is that variable, the vector that you connect there, and the second one is the one that you connect there. Okay, so if you have your h, let's connect it here. Okay, so h is the second variable, so it's u2. Now you can have something which is a constant flow. And the constant flow, let's put here something sources. Okay, constant flow, you pick up a constant. And you connect it there. So this is my u and this is my h. I can write it even here. U and h. Okay. Now I have to edit it. This is h, so it's the second one. And then I have to add plus, it's 1 divided by capital A, which is 1 times u. So it's u, the first component, is this variable here. Okay, don't get confused of this u with that u. Okay, this u is the vector here, is the default name of this vector here. And this vector here depends on what you connect to this so-called multiplexer board. Now let's see what happens when you do the simulation. Probably we need to adjust this stuff here. So let me go to MATLAB. It's a lot of water entering, so the level is going faster. So let me let me have a smaller value of u. So instead of having 1, I will put 0.3 or 0.03. I could have defined it there. So remember clear. And do the simulation. Okay, and it reaches some equilibrium. You see, this equilibrium is physically, it's when the input flow equals the output flow. Now, what is really important here in this example is the story. You have two things: the story of the nonlinear function and the story of the multiplexer to tackle vectors. Okay. Any question?
No.
So try to play a little bit now with this. Remember, I will send you the record of this lecture.
Thank you.
Thank you.
I will stop now
I will-
recording.
I will also